Hey guys, welcome back. It's time for us to start our conversation about the optimizations that have been made to the idea of using these GRE tunnels. As an example, we saw that we had to go to each end of the individual link to build a point-to-point connection that required a number of things. It required administrative time, and it also required us to be able to assign specific IP addresses. And as we know, IPv4 addresses don't grow on trees anymore. Now, the main thing that we want to look at right now is what was necessary, or what the industries looked at doing in order to be able to optimize the connectivity such that we really can step back and not visit the hub quite as much with regard to doing configurations. Now, what we see right now is exactly what we have on the board. We have three tunnels. We have tunnel 25, we have tunnel 24, and we have tunnel 26. Now, like I said, each of them have their own /24. We could have used smaller address ranges, but the main objective here is this is going to be intensive, especially in the context of doing configurations on the hub. We want to be able to avoid that, or at least streamline the process when and where possible. And that introduced a new technology that entered into our deployment arena called Next Hop Resolution Protocol. Now, what Next Hop Resolution Protocol does, it allows the individual endpoints, like for instance R5, 6, or R4 in our topology, to be able to register with a hierarchically constructed entity that we're configuring called an NHS. The NHS stands for our idea of a Next Hop server. So NHS is typically going to be configured as our hub. Now, what we also want to understand here is that Next Hop server and our Next Hop resolution protocol work together. What we do is we tell the spokes where to find the Next Hop server. We're also going to entertain the fact that in order to make all of this come together and be functional, what we're going to do is we're also going to have to make a modification to the hub, whereby we're going to use another protocol called MGRE, Multipoint GRE. Multipoint GRE is what enables this entire process. Now, when it comes to the way things are broken up with regard to how Cisco's presenting these concepts in the version 5 routing and switching exam, we need to understand a concept called phases. A phase 1 DMVPN, simply put, is going to be a DMVPN configuration that only has one device operating in multipoint GRE, and that's going to be the hub. The spokes are going to be communicating to the hub, and any traffic that is going to go from hub to hub must traverse from switch to spoke must traverse the hub. Now, the idea here is this is going to be our entry-level conversation about DMVPN. And in protocols like EIGRP, conversations about OSPF, that's predominantly going to be the tool that we use to demonstrate things, because what we need to realize here is the reason that we have DMVPN is twofold. The first reason is that Cisco understands the fact that this is something that's used on a day-by-day basis in the majority of networks all across the world. DMVPN is a very handy tool that overcomes a lot of situational problems. It supports encryption, it supports authentication, so it lends itself to environments that want to reduce the cost of not having leased line connectivity between sites, especially if we're not moving mission-critical information from point A to point B, as in across the internet. Because remember, we don't have any real quality of service mechanisms in the transport when we connect devices via the internet. Now, the other objective here is we wanted to minimize administrative configuration with regard to how we are going to be jumping around. And the idea here is that through this idea of designating a Next Hop server, what we do is we're telling the hub, allow devices to actually register with you and create a stateful list of information that can actually be sent to all other spokes in our environment. This is going to be how spokes are going to negotiate our configurations with regard to knowing that they can reach each other. But in phase 1, it's important to understand that they can't go directly from spoke to spoke. Later on, in phase 2, we're going to find that we can support a dynamically created tunnel between spokes using information learned from the Next Hop server, aka the hub. And what we're going to find there is that's going to be an extremely reliable efficiency mechanism with regard to sending information in our infrastructure. Now, the third phase, much ado about nothing, to be perfectly honest. It's just a few configuration commands in the context of our CCIE Routing and Switching version 5 exam, because what we need to understand here is we are only tasked with knowing about the ideas and concept behind single hub deployments. We don't have to have multiple hubs. We don't have to have virtual or overlapping overlays or VPNs. It really just boils down to the fact that we're going to have a hub and a series of spokes. And depending on the instructions that we receive on the lab, we're going to be creating a scenario whereby we have spoke to hub reachability, and any spoke to spoke must traverse the hub, phase 1. Or we're going to have spoke to hub, or we're going to have spoke to spoke through the creation of dynamic GRE tunnels based on information learned from the hub or the next hop server. And then lastly, what we'll find out is that phase 3 is merely a series of optimizations that are going to allow us to more efficiently create dynamic tunnels, but there's not a lot of change between phase 2 and phase 3. So what we're going to do right now is let's take a look at what we have currently running, because what we want to do is we want to take these 3 interfaces that we've built, these tunnel interfaces, 25, 24, and 26, and we want to amalgamate them under one interface. And what I'm going to do is I'm going to grab my eraser here and I'm going to take this out and we'll make everything a little bit clearer. So what we want to do is we want to build a VPN that works more like this. This is going to be a series of tunnels that we're going to create, but they're all going to terminate on one logical interface. We'll say tunnel 0. And what we also get is the ability to be able to come in and say, let's use a range of addresses such that we have the same subnet mask on every device in our tunnel configuration. Now what we're going to find here is the first thing that we need to do is we're going to have to change this to something called an MGRE, a multi-point GRE tunnel. Now, before we do that, let's take a look at what's actually running on our hub. I'm going to say end, and I'm going to say show run all, and I'm going to say section, or let's see, show run all, section, tunnel, and let's take a look at one of these tunnels. Let's say tunnel 24. It's not going to give me an output. So show run all, begin, interface, tunnel, show run all. It always happens every time I try to be selective. I never can remember the exact output. So let's see what we got. Now, as you can see, we've got a lot of information here that ordinarily wouldn't be visible for us. So let's do this. Show run, interface, tunnel 0, or tunnel 24. There we go. This is what I need right here. So I'm going to say show run all, section, there we go. And you're going to see all of the configuration under this individual interface. So here it is, tunnel 24. Now what we see here is that notice we have a number of components. We've got things for our PIM configuration, we got things for multicast fib, we've got Ceph configuration, we have default IGMP configuration, we can see what the load interval is based on calculations for things like being able to compute quality of service mechanisms, IPv6 configs, and what I want to do right now is I want to look at these tunnel configs. Notice here we see a tunnel source that's serial 2/0. My mode by default, like I said, is GRE for IP. The tunnel destination was configured. The tunnel has a TTL. We also have a bandwidth transmit and a bandwidth receive configuration. And pretty much that should take us for everything that we need to talk about right now. There's going to be some other configuration, but what I want to point out here is the mode here is, like I said, by default, it's going to be a regular GRE tunnel. Now what we want to do is we want to change that behavior. And what we're going to do is we'll entertain that by first removing the 3 interfaces on 2 and then giving it the IP address that we said that we'd list in this 10.10.10/ or .0/24 range. So first of all, let's get rid of these tunnels. No interface tunnel 24, no interface tunnel 25, no interface tunnel 26. Let's create a new interface, interface tunnel, and we said we'd call it tunnel 0. Let's give it an IP address of 10.10.10.2/24. Now, the moment we look at this, what we're going to see is that, again, we're going to have basic configuration, but what we need to recognize is the fact that we are working as a GRE tunnel. We need to change that behavior. How do we change it? Well, we go tunnel, mode, GRE, multipoint. We just turned the hub virtual interface tunnel 0 into a multipoint GRE configuration. Now, we're going to realize here in a phase 1 DMVPN, which is what we're building, only the hub is going to be configured for the idea of multipoint GRE. The individual spokes are going to be configured exactly the way they were. And what I want to do is I want to entertain two concepts, because it's important for us to understand in DMVPN we have dynamic mapping and we have static mapping. We mentioned the NHS. If I do not want to utilize a device as the next hop server, what I need to do is I need to statically make my configurations. So let's take a look at this. Now what we see here is do show DMVPN. And what we see is that we have no output. Now at some point this is going to change. What I want to do is I want to walk through this step by step by step with regard to the configurations, because in a multipoint GRE we do not specify a destination address. We're going to learn those either through the NH server, the next hop server, or through static mapping. Now what I'm going to do is I'm going to come in here, and the first thing I'm going to do is let's do this the easy way. Let's do a configuration where we're going to learn it dynamically. So what I'll do is first of all go ahead and create this config. So we'll come in here and say tunnel mode GRE multipoint. The next thing we're going to do is we're going to say IP NHRP, and what I'm going to do is I'm going to tell the system that we need a network ID. And what I'm going to do is I'm going to make a network ID of 25, we'll go ahead and write it here, 2456. That's going to be our network ID. So this is our NHRP network ID. So with that being said, we said 2456. Do show run interface tunnel 0. We have our IP next hop resolution protocol network ID 2456. We're operating in a multipoint GRE. Does this make us do show DMVPN? Does this make us operate with dynamic multipoint VPN? And the answer to the question is no. But what we want to do is realize exactly what's happening here. Remember, this device is a next hop server. It's going to wait for the spokes to attempt to try to register with it. But the thing is we have a missing configuration. Like I said, we don't specify a destination, but we still have to specify a source. So my tunnel source is going to be serial 2/0. So let's repeat our show command. Okay, notice we have IP NHRP network ID. We have our tunnel source 20. We have our tunnel mode GRE. Now what I want to do is I'm going to go to one of our spokes. Let's go ahead and go to R5. What I want to do is on R5 I want to remove that interface. So config T, no, interface tunnel 25. Now let's go ahead and create tunnel 0. Interface tunnel 0. IP address 10.10.10.5/24. And we'll say tunnel mode GRE IP. We'll go ahead and just do it. That's a default configuration, but I want to put it in there. Remember, Cisco can always go in, especially in like a troubleshooting section, and make a configurational change that ordinarily would not show up because a default operation may be in place. I mean, it's always inside the realm of possibility that things like Ceph can be turned off, and they can use those to impact other protocols or other sections of the exam. So right now what we see here is we see tunnel mode GRE IP. We're going to come up here and we're going to say IP NHRP NHS next hop server. So what we're going to do is we're telling the spoke here how to communicate with the next hop server that's configured on the hub. Now when we come up here I'm going to say 10.10.10.2. Now that may sound odd at first blush because the address that I just entered here is an address of the tunnel, but the tunnel's not up. Well, it's important for us to understand, just like in things like frame relay, what we need to do is we need to make mappings. And we have a set of commands available to us to be able to do that. That command is going to be IP NHRP map. And what we're going to do is we're going to say tunnel mode GRE IP. Now what I want to do is I'm going to go to one of our spokes. Let's go ahead and create tunnel 0. Interface tunnel 25. Now let's go ahead and create tunnel 0. Interface tunnel 0. IP address 10.10.10.5/24. And we'll say tunnel mode GRE IP. Map 10.10.10.2. So the address of 10.10.10.2 is on the tunnel, but I need to know an actual NBMA address that's going to allow me to reach that. So I'm going to use the physical address on R2, 183.123.2. IP NHRP map. Now let's see if this has made a change. Because remember, we want a DMVPN configuration to come up and become operational. So where am I going to look at this? Well, I could look at it here, or I could look at it on the hub. The hub is where I want to focus our time. So we'll come up here to the hub and say, do show DMVPN. Still nothing. Now, what I want to do is I want to illustrate the other element here. Let's take a look at what's going on R5. Let's take a look at under that configuration. Do show run interface tunnel 0. Well, we haven't configured the whole tunnel. So let's go ahead and do that. We'll say under this interface, I'm going to say tunnel mode. Actually, we already got the tunnel mode. Notice it's not visible. We're going to say tunnel source, serial 20. My tunnel destination is going to be 183.123.2. And see if the tunnel comes up. And you can see right here behind me says tunnel is up. Now let's go up to R2 again. Again, do the show command of DMVPN. Still nothing. So let's go down to R5 and make the other configuration, which is going to be very important to us. Do show run interface tunnel 0. The other configuration that we're missing here is that IP NHRP network ID. So let's come in here and say IP NHRP network ID, we said 2456, and I'm going to hit enter. Now let's see what happens on the hub. Notice now we have learned something. Now let's go through this. It's important for us to understand how to interpret this. Notice it's using the NBMA address, the non-broadcast multi-access address. That is going to be typically, if we were doing this across the internet, this would be our routable IP. So this would be typically public. Now notice it's being resolved or mapped to a tunnel address, and that tunnel address typically is going to be private. Doesn't always have to be, but it's going to be important for us to understand that that's what's happening. This is the mapping. The last element here is notice that I have a state of up and I have my up down time, and I have this idea here of an attribute. The attribute that I want to highlight right here is going to be D, which tells me it was dynamically learned. Now I mentioned the fact that we have dynamically learned information and we have statically learned information. Now let's look at the difference. If I come in here, and I'll go ahead and erase this. If I come in here on this device and I execute the do show run interface tunnel 0, what do I see? I don't see any information here telling me where to go to communicate with another device. There's no mapping here. Now in the confines of the spoke, we can see immediately by coming down here and say do show DMVPN, we see now we have an S. The S stands for static. The static configuration came into being because do show run interface tunnel 0, we told it what address to use, and we mapped it directly and told it how to communicate with the NHS. So what we see here is this configuration right here is a static mapping. Now we could have used static mapping on the hub. There was absolutely no requirement that we use dynamic, but what we're trying to do here is illustrate this process whereby we're bringing these links up, and notice I have not had to revisit the hub in any of these configurations. Now, there's some missing pieces still to the equation, but I want to illustrate just how simple it is to bring up these links when we start working with DMVPN. So what I'm going to do is I'm going to go over to R4 and R6, and I'm going to bring up the rest of the configuration. So here we'll say config T, no interface tunnel 24, interface tunnel 0, IP address 10.10.10.4. I'm going to say my tunnel source is going to be my serial 20 interface, and my tunnel destination is going to be, tunnel destination is going to be 183.123.2. Okay, now Do we have everything we need? No. Do show run, interface tunnel 0. We're missing any of the information about our next hop server. So let's go ahead and add that. So IP NHRP, NHS. The NHS is located at 10.10.10.2. How do I get there? IP NHRP map. To get 10.10.2, I need to use 183.1.23.2. Now again, let's go up to the hub and let's do the show command here for looking at DMVPN. Notice we have no other entry. We have no other entry because on this device, on I think we were doing R4, we have not configured the network ID. But this is something that I want to make certain that you guys understand clearly. And that is when you read documentation about DMVPN, it tells us that it's necessary for our network IDs to match. Well, what I want to do is I'm going to illustrate something here. I'm going to come down to the device that we were just working on. And what I'm going to say here is, first of all, I'm going to say IP NHRP network ID, and I'm going to do it backwards. Let's say 6542. Now, they don't match. Now, everything that I read, everybody that I talked to, all the videos that I watched when I was studying for how to do all of this stuff told me that that would stop the performance of DMVPN. Let's hop up to R2 and see if it actually did that. And what you see is I have 3.5, which I had before, and now I have 3.4, and I have connectivity. So, actually, let me do it this way, 3.4. So what we see here is it's necessary to have a network ID, but in a single hub deployment, it's not necessarily necessary that they match in order for our links to come up. That's something I want you to be abundantly clear on, especially if you get a troubleshooting question in the lab that asks you to do this. I don't want you to go down a blind alley because these things may not match. It's not going to prevent the creation or the registration of the spoke with the next hop server, nor is it going to stop intercommunication between our devices. So let's go ahead and wrap the rest of our configuration on the two remaining devices. So we have 4, and we have, I'll say the only one I have is 6. So let's do this real quick. Config T, no interface, tunnel 26. Interface, tunnel 0. IP address 10, 10, 10, 6, 255, 255, 0. Tunnel source, S20. Tunnel destination 183.1.23.2 to go to R2. And IP NHRP next hop server is located at 10.10.10.2. To get there, we use the map, IP NHRP map 10.10.10.2. We go to 183.1.23.2. And now what we need to do is IP NHRP network ID, and we'll go ahead and use the real one. So we'll do 2456. Now what we'll find is when we come up here to R2, we should see our third and final link come up and operational. So we have done everything here. We've got a multi-point GRE on R2. We have individual configured regular GRE tunnels operating on our spokes. Now let's see if we can actually resolve inter-reachability. So what we'll do is on R5, I'm going to see if I can do some pings. So we'll say end. Let's ping the hub, 10, 10, 10, 2. Let's see if we can ping R4, 10, 10, 4. Can we ping 10, 10, 5? And we see we have reachability to all of those. Now, can I ping? What I've done is I've pinged from R5 to R2, from R5 to R4, from R5 to R6, and I have resolved reachability. Everything is working exactly the way I want it to, and I actually drug my config over just a little bit. Let me fix that for you guys. I got a bad habit of accidentally dragging things to the right. One more time should do it. All right. So what we see here is exactly what we're looking for. We have all of these tunnels, we have all the reachability, but let's do some traces. Now remember, I told you that in a phase 1 DMVPN, if I do a trace route to 10, 10, 10, 2 to the hub, I'm jumping directly to the hub. Now let's go ahead and see if we can't hit 5, or let's see, 4. Notice we hit the hub, R2, and then we went to R4. So now what we need to do is hit R5 or R6, and we have the connectivity. But what we see here is the hub stays in the chain for every trace we send. So keep that in mind. It's very, very important, because in a phase 1 DMVPN, for me to have spoke-to-spoke reachability, my traffic must traverse the hub. Now, we got an issue here. Like I said, we've only halfway done our configs, and that's going to become evident the moment we come in here and we decide we want to start configuring routing protocols across these tunnels. So with that being said, what I'm going to do is I'm going to end this part of the presentation. I'll see you guys in the phase 1 DMVPN with EIGRP video. So I'll see you guys there. Bye-bye.